Okay, the first property we'll look at is that two vectors are equal or identical if they have the same magnitude and the same direction. Both things must be the same. The starting points may be different. So if we have a vector here and another vector of the same length and the same direction here or here or here, and they all are the same length and same direction, then they all are all equal vectors. Now, their effect on objects may be somewhat different, but so far as the vectors are concerned, they are the same vector. So if this vector is A, this vector is also A. They're all the same vector. Now, the second thing we want to see is if we want to add two vectors. And we'll see the graphical method first. So if we have a vector A that is like this, and a vector B that is, for example, like this, and we want to find the vector C, which is A plus B, then graphically we will first draw the vector A and then draw the vector B according to what we call the tip to tail rule, also called the head to tail rule. So this is the tail of vector A, and that's the tip of vector A. And that's the tail of B, and that's the tip of B. So the tip to tail means that the tip of one attaches to the tail of the other. So when doing A plus B, we first draw the vector A, same length and direction as the original, and we draw the vector B so that the tail is at the tip. So we move this whole thing here. It's going to be somewhat like this. So, well, you have to do this more carefully with a ruler and protractor and so on. So that's the vector B. And then starting from the tail to the tip, this will be C, which is A plus B. So the vectors, the sum of these two vectors is the vector C. Now you have to be careful. Sometimes people make mistakes. They would write the vector A like that and the vector B like this, which is wrong so far as addition is concerned. You have to write them like that. Another way is what we call the parallelogram way, in which we make a parallelogram. So it's somewhat like that. We make the vector A, same length and direction as before. We make the vector B, and then we make a line parallel to A, and we make a line parallel to B, and then this becomes A plus B. Okay, so it doesn't look exactly the same as that, but that's because the drawing is just freehand. So do it more carefully and you will get a better result. Now, vector addition is commutative. And commutative means that A plus B is the same as B plus A. So you can add them in any order you like. So you can write first B and then A. And in this case, if we write B plus A, we first draw the vector B and then the vector A. And then, well, that will be A plus B. It should go all the way to the tip. It should go right up to there. Now, if we have more than two vectors, for example, A, B, C, and D, and well, A is like that, and B is like this, and C is let's say this way, and you want to add all three of them, then we can add them in any order we like. The resultant, which is A plus B plus C, is going to be first the A, then the B, and then the C, and then this will be the resultant. And you can add them in any order you like. So if you first put the A and then the C and then the B, the result would still be, or should be, exactly the same as before. It does not matter what order you're adding them in, because it's commutative. Now the next thing is the negative of a vector. So if you have a vector A that's like this, then what's the vector minus A? In this case, we're multiplying the vector with a negative number, and what that does is it flips the vector over. So the direction of A was theta, the direction of minus A is going to be 180 plus theta. So it flips the vector by 180 degrees. It just makes it go in the opposite direction. The length remains the same. Now, if we were to multiply a vector by a number, so for example, we have 5 newtons at 30 degrees, so that's a force. If I have 3 such forces, all in the same direction, so it's the same force, and we multiply by 3 because there are 3 forces, it becomes 15 newtons at 30 degrees. The magnitude is multiplied by 3, but the angle remains the same. So we never change the angle in this way, we just change the magnitude. So if we were to draw this, a vector 5 newtons at 30 degrees is here, this angle is 30 degrees, and this is 5 newtons, then multiply that by 3 means simply making it 2 and 3 times longer. The angle remains the same, the length is multiplied by 3. Now, if we were to multiply with a negative number, well, we did that already here. Multiply by minus 3. So if we have 5 newtons at 30 degrees multiplied by minus 3, then that's the original vector A. We multiply with 3, make it 3 times longer. So that's 3A, and when you do the negative, it flips it over, and so this becomes minus 3A. So when you multiply with the negative number, it flips it over, and multiply by 3, it makes it 3 times longer. Now we go to the last thing, which is subtraction. So we will subtract one vector from another. So let's suppose our vector A is like this, and our vector B is like this. And what we want is A minus B. So in this case, we will write it as A plus of minus B. So we'll take the negative of B and add it to A. And the negative of B is going to be like this. And now we add A and negative B. So that's going to be A, and the negative B is going to be here. So this will be A minus B. Now we need to remember that A minus B is not the same as B minus A. The plus is, so A plus B is the same as B plus A. But A minus B is not the same as B minus A. Okay, so that ends this, and there are examples in the module on Canvas, some solved examples, so you can look at the examples there. So we'll save some time here without doing the example.